Hello everyone, welcome to Chemistry EduHub channel. In this video, we are going to talk about the second theory of acids and bases called Bronsted-Lowry theory. Now this theory was mainly proposed in order to overcome the drawbacks that we have seen in the case of Arrhenius theory. So according to Bronsted, an acid is a proton donor, a base is a proton acceptor. That means whichever a substance which can donate a proton, that is called a Bronsted acid, and which can accept a proton is called a Bronsted base. Donating is nothing but giving, accepting is nothing but taking. Let us understand the Bronsted theory clearly with two examples. Here, these two reactions are reversible reactions. This double-headed arrow indicates the symbol of equilibrium or the reversibility nature of the reaction. That means the left side ones are the reactants, right side ones are products. So once the reactants convert into products, again the products also will convert back into reactants. That is the meaning of reversible reaction, just like water turning into ice and ice turning into water. Okay, so these two are reversible reactions. Now, here we know that HCl is an acid and ammonia is a base. So, what is happening here? Ammonia and acid are added to the water. So, you can see HCl turning into Cl minus. That means HCl is donating a proton, that is H plus, to water, and it is turning into Cl minus. So, since this is an acid, it is turning into its conjugate base, or you can say it is a base obtained from the acid. Similarly, if you see water is accepting a proton from HCl. That means this is accepting a proton or proton acceptor, and it is turning into H3O plus. So since it is accepting a proton, it acts as a base, and this is an acid. Similarly, if you see the below reaction, ammonia is a base, it is accepting a proton and turning into ammonium plus ion. So this is its conjugate acid, and similarly the other species is going to be the acid, that is water, and turns into OH minus, and this is the conjugate base of H2O. So you can observe here there are two different sets of molecules formed here in each reaction. So HCl turning into Cl minus and H2O turning into H3O plus in the first reaction. Similarly, ammonia turning into ammonium plus ion and H2O turning into OH minus ion. So here, what do you observe the common point? There is a difference of only one proton. HCl has one proton, Cl minus has no proton. H2O and H3O plus, there is a difference of only one proton. Similarly, ammonia, ammonium plus ion, there is a difference of only one proton. Water and OH minus, there is a difference of only one proton. Such pair of acid and base which differs only by one proton are called conjugate acid-base pairs. What are they called? Conjugate acid and base pairs. So simply, acid minus a proton will give you its conjugate base, and base plus a proton will give you a conjugate acid. Bronsted theory explains the concept of amphoteric solvents. For example, if you take water as a solvent, it can both act as an acid and a base. How? It can lose proton by forming OH minus, or it can gain proton by forming H3O plus. Similarly, if we take ammonia as a solvent, it can lose proton to become NH2 minus, and it can gain a proton to form NH4 plus. So a solvent like water and ammonia can both act as an acid and a base. Such solvents are called amphoteric solvents. And according to Bronsted-Lowry theory, the neutralization is nothing but the transfer of a proton, that is H plus, from an acid to a base is called neutralization. Suppose if you take HCl and acid, it gives proton to H2O that turns into H3O plus and Cl minus. So here we observe the transfer of this proton from HCl to the H2O to form H3O plus. Such reaction is called neutralization according to Bronsted-Lowry theory. This theory also explains the strength of acids and bases. As we've already discussed in the previous video, that the acids can be strong and weak and bases can be strong and weak, but here the definition is a bit different. So we say that whichever acid has the greater tendency to donate a proton, such acid is called a strong acid. If it has a weaker tendency or lesser tendency to donate a proton, then it is called a weak acid. So what do you mean by tendency? It is the willingness to give. Which readily gives a proton is a strong acid. Which will not give a proton easily is called a weak acid. Similarly, if it has a greater tendency to accept a proton, greater tendency to take or accept a proton, then it is called a strong base, and which has a weaker tendency, then it is called a weak base. So here we are understanding the concept by using the same example every time so that it will register easily to you. So we used HCl with water, it turning into hydronium ion and Cl minus. So we know that HCl is a strong acid because whenever you add HCl to the water, it will readily split into H plus and Cl minus ions, and these H plus ions will be readily taken by H2O. But if you take Cl minus, it will not be willing to take a proton very easily, and hence the strong acid liberates or turns into a weak conjugate base. So if the acid is strong, its conjugate base is weak. Similarly, if the base is strong, its conjugate acid is weak. So this way, Bronsted theory explains the strength of acids and bases based on the tendency of donating a proton and tendency of accepting a proton. So hence, in a conjugate acid-base pair formed by the transfer of a proton, if one is strong, the other has to be weak, and if one is weak, the other has to be strong. This theory also has some limitations or drawbacks, so which includes it could not explain the acidic behavior of non-protonic compounds like CO2, SO2, AlCl3. So these compounds do not have proton. Non-protonic means no proton present in them, but still they are acids. How they are attaining the acidic behavior, Bronsted theory could not explain. And it could not explain the neutralization reactions in the reactions where there is no proton transfer. That is, suppose if you see calcium oxide taking carbon dioxide to form calcium carbonate. So this is also an example of neutralization reaction where CaO is a base, CO2 is acid, so it is getting neutralized to form salt. But how it is a neutralization reaction was not explained because there is no proton involved in this. That is a drawback of Bronsted. And the acidity and basicity strength is explained only in the presence of other substance. That means if one is there, based on the tendency of the other substance, only we can tell if it is a strong acid or a strong base. But when there is no other substance, you cannot talk about the acidity or basicity. So these are the drawbacks of Bronsted theory. So if you still have any doubts, you can comment in the comment section. I can explain. Thank you.